Good day, folks. Welcome to my YouTube channel. I'm doing the paper 2 November 2024, but the focus is the rate of reaction. Even in this question paper, I'm not going to do the entire question. I'm going to focus on the stoichiometry, which is the 6 marks question. The other question, I think, as you can easily do them, right? Now, the statement, it says the reaction between the pure aluminium, that word pure means it reacts completely. It's going to react completely. Aluminium react with an excess of hydrochloric acid. That means the aluminium is limiting, right? Is used to investigate the factors that affects the rate of reaction. Now it says the balance equation is as follows. It's aluminium and hydrochloric acid gives the salt and the hydrogen. I'm going to leave the definition there. Now in experiment 1, it says in this experiment 1 mole per dm3 of HCl react with 0.5. That's very important, of aluminium strip. Aluminium strip from an aluminium roll at room temperature. This is the amount that reacted completely of a limiting. Very important. Now it says the graph of volume of hydrogen versus time for this experiment is not drawn into scale. So this is the graph of the gas forming of the product, which is the hydrogen. This is the graph of the hydrogen that was produced today. It was captured, it was measured per time interval. But what we see in the graph, we are only told that 5 minutes, there's an amount of volume that we need there. There's an amount of volume that was produced at 5 minutes when the reaction was not complete here. Remember, the reaction will be complete there, which is later. But at 5 minutes, we needed that volume. What was the amount of volume that was produced at that time? But the question is not asking for that. Now it says for the time interval T0 to T5 minutes, which is from there to there, the average reaction rate for the formation of gas is 0.033 dm3 per minute, right? This is the rate for this time, for this period, guys. Remember, it's just in 5 minutes, within 5 minutes, right? Now it says the question, calculate the mass of aluminium present in the container at a T5, right, guys? From this amount, guys, this is the amount that reacts. But at 5 minutes, there's still an amount there. Remember, the reaction is not complete, and this amount of aluminium has not been used up completely. So there's still an amount that is used and still amount that remained. We wanted that amount remain at that 5 minutes. So what is going to assist us here is the rate and time. So that we can get this volume of hydrogen. What is a volume of hydrogen that is produced at that 5 minutes, right? So what we're going to do there, step number one, what we're going to do, we are going to use the rate. Rate is equal to change in volume over change in time, right? What do you need to remember here? This is an initial. There was nothing initially. It's a 0 volume at 0 time. Then here at 5 minutes, we want that final volume there, right? That's the volume we want. So it's going to be V final minus V initial divided by T final minus T initial, right? Now we're going to substitute. Let's substitute now. Substituting the rate, it's 0.033, and then the final volume is the one that we want, is the volume that is produced finally there at that 5 minutes, and the initial is 0, and the time, it's 5 minutes. The T final, it's 5 minutes there. So we're going to put 5 minutes minus 0, and then we do the math. When we cross multiply there, all right, we're going to have a V final and 5 there, and the same amount there, and then we cross multiply. So the V final for the hydrogen, that's the volume that is produced at that moment. So it's going to be 0,165 dm3. How do we know it's going to be dm3? The minute and the minute in that is going to cancel, and we're going to be left with dm3 there. Right, step number 2, having that volume. So we're going to find the amount that reacted. The amount, having this volume now, we're going to change this volume into number of moles. Remember, we're told that this is a molar, this gas has been produced at molar gas volume, right? So we're going to change the volume into number of moles. So the volume to number of moles. We're going to say number of moles of hydrogen gas is equal to V over what? Vm. Right, and then we substitute the volume there. It's going to be 0,165, this one, and then we divide by the molar gas volume, which is 24.5. We divide by 24.5, and then the answer, it will be 6,74 times 10 to the power -3 mole. Right, guys, there's nothing wrong if your answer is in decimal places, right? Now that we have the number of moles of this, we can get the amount that reacted with this one. Doing the mole ratio of hydrogen is to aluminium. So step number 3. So we want the number of moles of aluminium is equal to the ratio there, guys, is 3:2. So it's gonna be 2/3 times the number of moles of what? Of hydrogen. Guys, it's the same as when you say hydrogen is to aluminium. The ratio is gonna be 3:2. 3:2, and you put an X there, and then here you're going to put 6.74 times 10 to the power -3 is the same as this is the same thing. It's the same thing. So we're going to cross multiply there. So if you see there, you're going to have 3x is equal to 2 times the 6.7 times 10 to the power -3, and then we divide by 3. Do you see the 2/3 comes from where? And then we multiply by the number of moles. This is the number of moles of what? Of hydrogen. So it's 2/3 times 10 to the power 6.74 times 10 to the power -3. So the answer for that is going to be 4,49 times 10 to the power -3 mole. This is an amount, remember, this is an amount reacted, right? It's an amount of aluminium reacted. This is an amount that is formed, right? So the next step now, we know the amount that reacted, so we wanted the amount that remained. So we're going to change this number of moles into mass. We're going to say number of moles to mass. We're going to say number of moles is equal to mass over molar mass. So we take that number of moles, 4.49 times 10 to the power -3, the mass, the molar mass now. The molar mass of aluminium is 27, right? And then when we cross multiply there, the answer is going to be the mass. This is the mass of what? Of aluminium. This is the mass of aluminium reacted still. It's going to be 0,12 grams, right? This is the same number of moles reacted. It's just that you convert it into mass, right? And then step number 5. Now we're going to get now the mass of aluminium. The mass of aluminium remained. That did not react. We'll take the initial mass. The initial mass, do we have the initial mass? We must have the initial mass minus the mass that what reacted or used. Do we have the initial mass of aluminium? Let's look in the statement. Yes, we have. This was the mass that was used there. So we're gonna minus the 0.5 minus what? 0.12. 0.12. So the answer is gonna be 0.38 grams. So we are done with that answer. That's it, guys. I hope the stoichiometry part it makes sense. Cheers. Bye.